Welcome to my lab. Are you ready to learn? Yeah! Are you ready to have some fun? Yeah! What I'd like to do next is an experiment using this tall cylinder that I have here. It is sitting on a magnetic motor. There is a spin bar down there, and I have the ingredients for the experiment. Here are the, whoops. I'm missing one ingredient. There are 3 ingredients, I'm missing one. Could someone please bring me the missing ingredient? I'm missing the ingredient for this experiment in the... Hello, Bucky. Welcome to my lab, Bucky. And thank you for bringing, let me see, is that what I want? That is exactly what I want. So Bucky, I would like you to help with this experiment. I want everybody to see that Bucky is a very good science student. He has goggles. You see that, right? Right? And Bucky also has a science is fun button right here. Bucky is a fabulous science student. So let's do this experiment together, Bucky. So what I'm holding up here, what does it say on it? Milk of magnesia. So Bucky, would you shake this up for me? Just shake it up. Yeah, real well. Right? Okay. All right. And then you hand it to me. Thank you. I'm going to take some of the milk of magnesia and put it right here. And see, it's not dissolving very well, is it? So Bucky, the missing ingredient that I had is right here. Can you help with this experiment, Bucky? All right, you put a little bit up there at the top. Yeah, put in some. Yeah. That's good. Very good, Bucky. Very good, Bucky. And so there's a color change. Yes. So what we have here is a mixture of acid-base indicators. The magnesium hydroxide, which is in the milk of magnesia, is basic. So Bucky, we have an acidic liquid here. Can you tell what it says here? What is it? Vinegar. Okay, Bucky, add a little bit of vinegar into the cylinder. Let's see what happens. Just add a little bit. Yeah. Not much. Don't be afraid. Go ahead, Bucky. Okay, that's good. You see the colors of the rainbow, right? Right? Okay, Bucky, a little more of the vinegar, please. Bucky likes doing this experiment, I can tell that. All right. So we have an acid-base reaction taking place. Bucky, add some more, please. Like a lot more. All right, the whole bottle will flow out. We can't put the whole bottle. But look at the beautiful color changes. Fabulous transformation. Bravo, Bucky. So, Bucky, as I said, is a very good student. Bucky is going to graduate in 4 years. Everyone is going to graduate in 4 years. Let me see that again. 1, 2, 3, 4. I have 5. Well, we're different, but you're going to do it in 4 years. Fantastic. And in order to graduate, you have to pass your final exams. I know it's final exam time here, and you have to go study and prepare for the final exam. Bucky, thank you so much for coming and joining this very special celebration. Thank you very much, Bucky. Thank you. Thank you, Bucky. Quite a character, right? In this experiment, I'm going to use 3 beakers. 2 of them have a blue liquid, and 1 has a clear and colorless liquid. Behind the 3 beakers are 3 containers that have clear and colorless liquids. And what I'm going to do is pour some of this liquid, which is ammonium hydroxide, into this blue liquid, which is copper sulfate, and we'll see what happens. You get a beautiful color change. You also get a little bit of not so soluble substance at the bottom. To the next beaker, I'm going to take hydrochloric acid and add it to copper sulfate again. And let's see what happens. More? More is better, right? Not always. Sometimes it's just more. And now we see another beautiful transformation. The color changes tells us that a chemical reaction has taken place. Now, I really want you to pay attention to this one here, because I have a clear and colorless liquid, and here I have another clear and colorless liquid. And watch, you're paying close attention, right? See what happens when I add just a little bit of that. Isn't that fun doing this? So what I added was some lead nitrate into a solution of potassium iodide. If you study science, if you know what you're doing, and you obey all the safety rules, you not only can have a lot of fun, you can help advance civilization. What I'd like to do now is an experiment using this mug. Can you see what this mug says on it? Oh, let's see if we can get a better shot. There it is. Right? You see that? Right? Huh? Are we having fun? Well, let's see if we can have some more fun. All right? So the question I have for you is this. Do you suppose there's a way for me or for you to suspend this mug up in the air without touching it? Do you suppose there's a way for me or for you to suspend this mug up in the air without touching it? Yes or no? Some people are saying yeah, some people are saying no, some people don't care, right? I want you to pay attention and care, because everything we do is fun in my laboratory. So what I'm going to do is reach into my pocket and get out a balloon. And I'd like to watch carefully what I'm doing as I put the balloon inside the mug and inflate the balloon. Ta-da! Is the mug suspended up in the air? Am I touching it? Is this an experiment you can do at home? Yeah. Make sure you put a cushion down here. All right, I'm going to try to pull it out. Oh, okay, balloon is bent out of shape here. Right? So what I would like you to do is to think about the explanation as to why this has happened. I'm going to let the air out of the balloon, so let's set it down here. What's the explanation for this? Some people say it's because the balloon created some pressure inside the mug. So what I've done is I went to the glass shop that we have here, and I sewed off the bottom of this beaker so I can put my hand through it. And I'm going to do the very same experiment using the very same balloon and see what happens. Here we go. Ta-da! So pressure is not the explanation. There must be some other explanation, right? I'm going to give you a hint. You know the difference between a hint and a clue? A hint is something that someone gives you. A clue is something that you find. You know, you walk around sometimes and say, I have no clue. So here's my hint. I want everybody to rub your hands like this very fast. What do you feel? What's causing the heat? Could that be your hint? You think about it. Now I'm going to take another balloon, and I'm going to inflate this one. About that much. And then I'm going to tie it, and I want to ask you a question. Do you suppose there's a way for me or for you to suspend this balloon up in the air without touching it? It's the same question as before, right, about the mug, right? Is there a way to do it? Some people say yes, some people say no. Well, I suppose I could blow air on it like this, but that's hard on my neck. Suppose I reach for something that we have around the house. What is this? Suppose I take the balloon and put it up here. Is the balloon up in the air suspended? Am I touching it? What's holding the balloon up in the air? Air, there's air right now. The balloon falls down. What's holding the balloon up in the air? A stream of moving air. You know what? You can do this experiment. You can tilt the angle like this. See how far away you can get away with it. See? Isn't that cool? Right? There you go, right? You can also take a ping pong ball. And you can take a styrofoam ball. And you can take the balloon. Are these experiments you can do at home? Have fun. Enjoy. Think about the explanations. Always try to learn. Always ask questions. At this time, I would like you to welcome a special guest to my lab, a neuroscientist. I would like you to welcome Dr. Indre Viscontis. Hello, Indre. Welcome to my lab.
So great to be here.
What have you been working on?
So I'm really interested in how the brain works, how we see things, how we make sense of the world.
Do we always see things exactly the way they are?
Absolutely not. In fact, there are such things as illusions.
What's an illusion?
Well, I brought two types I'd like to show you today. I brought you an optical illusion and a visual illusion.
An optical illusion and a visual illusion. All right, I'm ready.
Yeah, you ready? Okay,
Yeah.
so I got to set it up over here.
Set it up over here. I'll get out of your way.
Thank you. All right. Oh, I'm going to do it this way. So an optical illusion is an illusion where there is something in between your eyes and what it is that you're looking at that changes how you perceive that object, okay? So first off, do you see two arrows here? Yes. Okay, are they pointing in the same direction? Yes. Yes. Okay, are we sure about that? Do I need to adjust them? Okay, pointing in the same direction? Yes. All right. What happens when I put a glass cylinder in front of one of them? Nothing. They're still pointing in the same direction? Well, that's not very exciting. Okay, well, what happens if I pour water into the cylinder? It changed direction, but again, the only reason is because there's something in front of our eyes and the thing that we're looking at.
So that's an optical illusion.
That's an optical illusion. You want to see a visual illusion?
I would love to see a visual illusion.
So
yes.
A visual illusion happens entirely inside our brains. There's nothing between our eyes and what we're seeing. It's only the brain that essentially creates the illusion. So, do you see these two red lines? Do they look exactly the same? No. One of them looks longer than the other, right? Which one? The one on the right. The one on the right looks longer than the other one, but if I move it across the screen, you'll see that in fact, it's exactly the same length. Sorry, that looks a little weird. Let's put it down. There we go. See, same length. But when it's over here, your brain interprets these lines as indicating that this line is actually further away from us, so it must be bigger. Our brain creates the visual illusion.
That's fascinating, Andre, really fascinating. Thank you.
But you know what? We're in your lab today, so
yes, we are.
Can we do some chemistry?
Of course.
Okay.
Did you bring your goggles?
I did. There's some right here.
All right, good.
Okay.
How about working with these two liquids?
Okay.
All right.
Very nice.
So we'll take. You will want to do the experiment, right?
I do.
So this is kind of a reddish liquid. There's a glass rod in there. This is a greenish liquid with a glass rod in it.
Okay.
And behind we have two containers with two different clear and colorless liquids. So how about mixing some of this liquid with the reddish one?
Okay.
All right.
Does it matter how much?
Well, try it.
Okay. How about a little? Oh, look at that.
All right. Add a little more.
Wow.
Mix them up a little bit.
Wow, it's turning green.
It's turning green indeed, right. The color of the liquid is turning green. Very good. So you change reddish to green.
Yeah.
Now this one is green, and this one is clear and colorless.
Okay.
So try that one. Let's see what you have there.
Wow, look at that. It's red. Red and green.
A little more. A lot more. All right.
I like your lab.
So we're back to green and red as we started.
These are holiday colors.
They are indeed.
That's great. So, you know, for me, the holidays are all about music.
About music.
Yeah. Because
Indre, I know that you are an opera singer.
I am.
Is there a chance you could sing a song for us, please?
Oh, I would love to. In fact, I have one prepared that I think is really quite appropriate. It's about a woman, a young woman, who is asking her parents for something that she really wants. Do you want to hear that one?
Yes, please, yes.
Okay. Well, first I need to get a note. So let's see if this is the right sound. Yeah, I think that might work well. Okay, so this is an aria from Puccini's Gianni Schicchi. Just as I mentioned, this young woman is asking her father to take her to the market to buy a ring, because if she can get a ring, then she can marry the boy she loves. All right, so let's see. Oh, mio babbino caro, mi piace bello, andare in Porta Rossa a compirar l'anello. Sì, sì, ci voglio andare, e se la massa intorno andrei sul ponte vecchio, ma per buttarmi in arno mi strago di tormento. Vorrei morire, babbo pietà, babbo pietà, pietà.
Wasn't that beautiful? You may have anything you ask for. Please give her another round of applause. A beautiful experiment right here. Would you like to do another science experiment?
Yeah, do we have one more?
We have lots more. So
Okay.
you want to help with one?
Okay, yes.
We need gloves for that.
Okay.
So we put our gloves because we're going to pick up those glass containers that have in them hot water.
Okay.
And of course you obey the safety rules too.
Yeah.
I saw you put your goggles on. That's very good. And what we're going to do is take the rubber stoppers off, pick up the flasks, and empty the hot water into the sink to your right over there.
Okay.
All right? We're just emptying the water. Just dump it out like this. Glug, 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 glug. Yeah, yeah. There it is, there it is. And then we come back here. We put the round bottom flask on the cork rings, and we take some of the liquid, actually all the liquid in this small flask. We put it in there. And then when ready, we take this clear and colorless liquid and add it there. All the way. And then we put the Rubber stopper back on. And we start mixing the liquids.
Whoa, it's
like
getting
so.
brown.
Ah, shake them. They're getting darker.
Yeah. Wait, something else is happening on mine.
Mine too.
Huh. Hey, I see you.
I see you too.
Wow.
Can the audience, can you see yourself? Yeah. So what we've done here is deposit a thin layer of silver inside those round bottom flasks, and what we've done is prepare holiday ornaments.
So cool.
It's very, very fun doing experiments in my lab, and it's been made much more fun with the beautiful singing that you provided. So thank you so much for coming.
Thank you.
Indre, we'll see you again soon.
Always great to see you.
Thank you.
Bye-bye.
For my next experiment, I'm going to do right over here. I have a spiral glass assembly with a funnel on top and the receiving beaker at the bottom. I'm going to mix two liquids, a clear and colorless liquid and a clear and blue liquid. And I'm going to mix them in the dark. So with the lights down, please. I'm ready whenever the lights are out. Here we go. Isn't that beautiful? With the lights up, please. This is a chemical reaction that releases energy in the form of light, not in the form of heat. I can touch it right here. It's at room temperature. Let's have a look at the monitor and see the same reaction in slow motion now. A beautiful flow mixing the two ingredients to produce what is called chemiluminescence. Can you say chemiluminescence? Chemiluminescence. Very good. Before you go to sleep tonight, make sure you know how to spell chemiluminescence, because this is how we learn. My next experiment is one where I'm going to use plastic bottles that have screws stuck on the sides. There's the cork on the top of each, a different cork on the top of each, and there's a clear and colorless liquid at the bottom. I want to show you a cutout of what's going on in there. So here's one that has the two screws. You can see they're not touching on the inside. They're not touching on the inside. There, you can see them much better now. And what I'm going to do is reach for a source of a spark. This device is called a Tesla coil. When I push the button, it produces a spark. What I want to do in this experiment is touch one of the screws to see if I can make the spark jump across the gap that separates them. So let's do this and turn the lights down. Let's see if we can see it now. Can you see it? Can you see the spark jumping across the gap? Okay, with the lights back up, please. Now, because we have a clear and colorless liquid at the bottom of each of these two plastic bottles, I'm ready to touch one screw, and here we go. Were you ready for that? Are you now ready for the next one? All right, here we go. You ready? Here we go. All right, give me a countdown. 1, 2, 3, right? Come on. 1, 2, 3. You have been a wonderful audience. I'm so grateful for the eruption of appreciation that you have given us. I'm so happy that you enjoy doing experiments. Thank you so much for sharing the joy of science. Thank you for coming. Thank you, everybody. Thank you.